Hey guys, welcome to 11.5 partial fraction decomposition. You're not going to see the connection today relating this to sequences and series. However, in the next section we will be combining forces and you will see why we had to learn this. So you've probably never done this before, but partial fraction decomposition is, when you're adding two rational expressions, you have to get a common denominator, and then you combine it into like one nice sum or difference. Well, partial fraction decomposition is going backwards. Can you take this and tell me what the initial rational expressions were? So we're just going backwards. All right, so here's how it works. Okay, so again, they're giving you the sum. You need to break it up into these smaller pieces that you added together. First thing you want to do is factor the denominator to see what the initial denominators were. So this would be like x plus 4 and x minus 3, right? So that means, let me get a darker marker here. That means when we write our initial fractions, it's going to be something over the x plus 4. I'm going to call it a, plus something over the x minus 3. Right? Those will be our original fractions. We had to have one with an x plus 4. We had to have one with an x minus 3. Okay, great. Then I want you guys to cross multiply, not cross multiply, but let's get a common denominator. So if you were to get a common denominator, wouldn't you multiply a by x minus 3? So that would be a times x minus 3 plus b times x plus 4. That's what you would do to get a common denominator. Okay, that would be the new numerator. And let's keep in mind that this new numerator is really equal to this numerator, which is 5x minus 1. Okay, now somehow we have to figure out what a and b are. And we're going to have to use a system. So let's do this. Let's collect all of the x terms and let's collect all of the constant terms. So here's what I mean. If you were to distribute, wouldn't this be ax minus 3a, and wouldn't this be bx plus 4b? If we were to collect all the x terms, wouldn't it be this one and this one? And if we pulled the x out, the coefficient of the x term would be a plus b. And then let's combine all of the constant terms without the x. That would be this one plus this one. So negative 3a plus 4b. And then don't forget, this is all equal to 5x minus 1. And now, look at this. Something x plus something x plus something. So it looks like if we make a system here, the a plus b must be equal to 5, because that's the x term, and the negative 3a plus 4b must be equal to negative 1, because that's the constant term. And now you're just going to solve the system for a and b. So you could do elimination, substitution, whatever you want to do. I'm going to do elimination by multiplying everything by 3. So this is going to be 3a plus 3b equals 15. And then this one's just going to stay the same. Negative 3a plus 4b equals negative 1. And then if you add going down and solve the system, you get 7b equals 14, so b equals 2. And then by subbing that back in, you obviously get a equals 3. And then final answer is just plug them back in to see what the initial fractions were. All right, so final answer, write the partial fraction decomposition. It would be A, so 3 over x plus 4, plus B is 2 over x minus 3. That's it. And then if you want to check your answer, add these together, get a common denominator. You should end up with this. All right, let's try one more of those. Okay, don't worry about, well, we'll do that later. Okay, so first step, let's factor the denominator to see what we're working with. And this would be x minus 3, x minus 2. So when we write our partial fractions, it's going to be a over x minus 3, and the other one's going to be b over x minus 2. And now remember, you're kind of like cross-multiplying. You're trying to find the new numerator if you were to get a common denominator. So that would be, the a would be multiplying by the x minus 2, plus the b would be multiplying by the x minus 3. And then let's keep in mind, this is the new numerator, so it's going to be equal to x in the end. And now the trick is you want to rewrite it so it's like something x plus something. All right, what would be the terms that would go with the x? If you need to distribute it out, go for it. This would be ax minus 2a, and this would be bx minus 3b. So we want to collect all of the x terms, ax plus bx, so this would be a plus b, and then the constant terms would be negative 2a minus 3b. And don't forget, this is all equal to x. So I know it's a little weird this time, but technically this is x plus 0. So now something x plus something equals something x plus something. So now we have to write a system. The a plus b is the coefficient of the x term, which is 1. So a plus b must equal 1. And then the constant term in this problem is 0. So negative 2a minus 3b equals 0. And then go ahead and solve that system. So I'm going to do elimination again. If I multiply everything by 2, I get 2a plus 2b equals 2. And then I get negative 2a minus 3b equals 0. So you can add going down. You end up with negative 1b equals 2. And then if you divide by negative 1, you get b is negative 2. And then we can easily find a. So if b is negative 2 and you add it over, 1 plus 2 is 3. So a is 3. All right, so final answer, the partial fraction decomposition is A, so 3 over x minus 3 plus B, negative 2 over x minus 2. All right, so we just went backwards to find the original fractions. Okay, there's one more that we need to do, and this one's a little bit harder. It's when there's a repeated factor. See how these have always been different? What if you have a repeated one? It's a little bit different. All right, so last one, guys. You can do it. Start by factoring out the denominator. So first we're going to factor out an x. And you'll have x squared minus 2x plus 1. But that can factor further. It's x times x minus 1, x minus 1. Or some people would write that as x times x minus 1 squared. Okay, so that's factored form of the denominator. Okay, let's set up our a's and b's and stuff. So we have a over x. That's the first term. Now here's the new part. When you have a repeated factor, like a squared or a cubed, you have to write it that many times. Okay, so our b is actually going to be the x minus 1 single. Then we have to add a c, which has the x minus 1 squared. So any power bigger than 2, one of them is going to be the single power version, and then one of them is going to be the double power version. If this would have been cubed, it would have been x minus 1, then x minus 1 squared, then you would have had a d with an x minus 1 cubed. Kind of tricky. Okay, so singles stay single. Doubles you have to write twice as a single and then as its double. Okay, that's the first trick. Now let's do the same thing. Let's figure out what our numerator would be if we were to get a common denominator. So let's get some brighter colors here. This is getting dark. Okay, so the a term, he's missing the x minus 1 squared. Right? Wouldn't that be what you would multiply a by to get a common denominator? Okay. Now the b has an x minus 1, but it's missing the x and another x minus 1. And then the c has the x minus 1s, but it's missing the x. So you have to be really good at getting common denominators here. All right, so this would be our numerator. And don't forget that's really equal to this numerator, which is x plus 2. All right, and then we could do all that stuff where you collect the terms and get it in terms of x and the constant, but there is a shortcut if anyone's interested. So you could make a system. It's going to be a little harder because there's an a, b, and a c. Here's a trick. What if we were to plug in x equals 1? What would happen? We would get a times 1 minus 1 squared is 0, plus b times 1 times 1 minus 1 is 0, plus c times 1 equals 1 plus 2, so 3. But anything times 0 just cancels, and bam, right away we just ended up with c equals 3. Now let's take another number to plug in that's going to make something be 0. On this one, I'm going to pick 0 itself. Let's plug in x equals 0. We would have a times 0 minus 1 squared, so negative 1 squared, plus b times 0 times 0 minus 1, which is negative 1, plus c times 0 equals 0 plus 2, so 2. Now this time anything times 0 just cancels, and you end up with 1a equals 2. Cool, so a equals 2. Now how did I know to pick these two numbers? I knew to pick 1 because it would make these 0, and I knew to pick 0 because it would make these 0. And now if you have a and you have c, let's just plug those in to find b. And for this one, you guys can pick any other number for x. This time, not 1 and 0 though. For this last one, I'm going to pick 2. It could be anything. All right, so I'm going to plug in 2 A and C, and now we're going to find B. All right, so A is 2 times 2 minus 1 squared. Oh, let's just do that. That's 1. Okay. Plus B times X. X is 2. Times 2 minus 1, which is 1. Plus C is 3 times X is 2 equals X is 2 plus 2, which is 4. So we should be able to find B now. 2 times 1 squared, that's just 2, plus this is just a 2B, and this is a 6. And then 2 plus 6 is 8. So now we have 2B plus 8 equals 4. And then just, this is easy now, right? Subtract the 8, you get negative 4. Divide by 2. It looks like B ends up being negative 2. And now that you have A, B, and C, we can write our final answer as A over X. So 2 over X plus B over X minus 1. So negative 2 over X minus 1 plus C over X minus 1 squared, 3 over X minus 1 squared. Don't worry, guys. If you have questions, we will answer them tomorrow. Okay, that is linear partial fraction decomposition. Thank you for watching.